Number 9. HD 1899733b. In 2005, astronomers discovered a planet 63 light-years from Earth that appeared stunningly beautiful through their telescopes. HD 1899733b glowed a deep cobalt blue, reminiscent of Earth's oceans seen from space. For a brief moment, it seemed we had found a familiar sight in the alien cosmos. We hadn't. What we found was one of the most hostile worlds ever observed. The blue color isn't from water. It comes from silicate particles suspended in the planet's atmosphere, tiny fragments of glass scattered throughout clouds of scorching gas. The temperature on HD 1899733b reaches 1,700 degrees Fahrenheit, hot enough to vaporize most metals. But temperature isn't what makes this world truly nightmarish. The planet's atmosphere moves at incomprehensible speeds. Winds exceeding 5,400 miles per hour, 7 times the speed of sound, tear across the surface in perpetual hurricane-force storms. These aren't vertical winds like Earth's tornadoes. They blow sideways, parallel to the ground, creating a horizontal maelstrom that circles the entire planet, and in those winds, it rains glass. The extreme heat vaporizes silicates in the atmosphere, which then condense into molten glass droplets. These droplets are caught in the hypersonic winds and flung sideways at speeds that would shred any known material. Imagine standing in a sandblaster loaded with molten glass, amplified 1,000 times over. What makes HD 1899733b particularly unsettling is how it challenges our assumptions about planetary habitability. We've learned to look for blue planets as potential havens for life, worlds that might resemble our own. But this cobalt jewel in the cosmic darkness is a reminder that beauty in space can mask absolute lethality. Sometimes the most Earth-like appearance hides the most alien reality. Number 8. WASP 12b. In 2008, astronomers discovered a planet dying in real time. WASP 12b orbits so close to its star that the journey takes just 26 hours, bringing it within 2 million miles of the stellar surface. At this distance, the planet experiences gravitational forces so extreme they're literally tearing it apart. The star's gravity has stretched WASP 12b into an egg shape, pulling material from the planet's atmosphere in a continuous stream of gas that spirals into the star itself. The temperatures on WASP 12b reach 4,000 degrees Fahrenheit, hot enough to break down water molecules and dissociate most chemical compounds into their constituent atoms. But what makes this world truly bizarre is its appearance. The planet is nearly invisible. It absorbs 94% of the light that strikes it, appearing as a dark void against the brightness of its star. Scientists believe the extreme heat has vaporized metals and other materials into the atmosphere, creating a haze of light-absorbing particles that trap radiation rather than reflect it. Every second, WASP 12b loses approximately 6 billion tons of material to its star. The planet is being consumed, devoured by the very object it orbits. Astronomers estimate that in roughly 10 million years, perhaps less, WASP 12b will cease to exist entirely, reduced to a dispersed cloud of gas absorbed into its star's outer layers. What makes this discovery particularly unsettling is the inevitability of it. We're not watching a sudden catastrophe or a dramatic collision. We're observing a slow, inexorable death, a planetary execution playing out over millions of years. WASP 12b cannot escape. It cannot stabilize. It can only spiral inward, growing hotter and more distorted until nothing remains. The universe, it seems, has no mercy for worlds that venture too close to their stars. Number 7. 55 Cancri e. 40 light-years from Earth orbits a planet where mountains are made of diamonds and rain falls as crystallized carbon. 55 Cancri e, discovered in 2004, is roughly twice Earth's size and 8 times its mass. But its composition is unlike anything in our solar system. This is a carbon-rich world, a planet where the most abundant element isn't silicon or iron, but pure carbon in its crystalline form. The planet orbits so close to its star that surface temperatures reach 3,900 degrees Fahrenheit, hot enough to melt most metals. At these extreme temperatures and pressures, carbon doesn't form the soft graphite found in pencils. It crystallizes into diamond, the hardest naturally occurring substance known to science. Scientists estimate that roughly 1/3 of the planet's mass could be pure diamond, a layer potentially hundreds of miles thick beneath a graphite crust. To understand the scale, consider this. If the estimates are correct, 55 Cancri e contains more diamond than has ever existed on Earth throughout our planet's entire history. Mountains of crystallized carbon rise from diamond plains beneath skies where carbon vapor condenses and falls as diamond rain. It's a world built from the substance we value most, rendered utterly worthless by its abundance. What makes 55 Cancri e particularly significant is what it reveals about planetary formation. In our solar system, planets are primarily composed of rock and metal, with carbon existing only in trace amounts. But 55 Cancri e formed in a region unusually rich in carbon, possibly in a protoplanetary disk, with different elemental ratios than our own. Its existence proves that planets can have wildly different chemical compositions depending on where and how they form. 55 Cancri E stands as a monument to cosmic irony, a world of infinite riches that will never be reached, never be touched, never hold any value beyond what it teaches us about the staggering diversity of worlds that exist beyond our small corner of space. Number 6. PSR B1257+12B, C, and D. In 1992, astronomer Alexander Wolszczan made a discovery that should have been impossible. Orbiting a pulsar 2,300 light-years from Earth were 3 planets. Not around a normal star, around the ultra-dense remnant of an exploded star, a cosmic corpse spinning at 161 rotations per second and blasting its surroundings with lethal radiation. These were the first planets ever discovered outside our solar system, and they orbited in the last place anyone expected to find worlds at all. Pulsars are what remain after massive stars explode in supernovae, collapsing into spheres just 12 miles across, but containing more mass than our entire sun. PSR B1257+12 spins so rapidly it functions like a cosmic lighthouse, sweeping beams of intense radiation across space with clockwork precision. The environment around such an object should be utterly sterile, scoured clean by the supernova that created it. Yet somehow, these 3 planets exist. They orbit in nearly perfect circular paths, suggesting they're not recent captures, but stable residents of this hostile system. Scientists propose 2 possibilities. Either these planets survived the supernova that created the pulsar, enduring temperatures of billions of degrees and radiation that would vaporize most matter, or they formed afterward, coalescing from the debris ejected during the stellar explosion, born from the ashes of their star's violent death. Both scenarios defy conventional understanding of planetary formation and survival. These worlds have been dubbed zombie planets, dead worlds orbiting a dead star in a system that should contain nothing but radiation and debris. They're bathed in energy levels thousands of times stronger than anything in our solar system, making them among the most hostile environments imaginable. The discovery of PSR B1257+12's planets forced astronomers to reconsider fundamental assumptions about where planets can form and what extremes they can endure, proving that worlds can exist in circumstances we once thought absolutely impossible. Number 5. J1407b. In 2012, astronomers observed something impossible passing in front of a young sun-like star 434 light-years from Earth. For 56 days, the star's light dimmed in complex irregular patterns, unlike anything caused by a normal planet. When researchers analyzed the data, they realized they were witnessing something unprecedented. A planet with rings, not modest rings like Saturn's. Rings so massive they span 75 million miles across, a distance nearly equivalent to the space between Earth and the Sun. J1407b's ring system is 200 times larger than Saturn's rings, the largest we've ever observed. If this planet orbited our sun in place of Saturn, its rings would dominate our night sky, appearing several times larger than the full moon and visible even during the day. The rings contain enough material to build dozens of moons, perhaps hundreds, with gaps in the structure suggesting that moon formation may already be underway. What makes these rings particularly mysterious is their stability. Rings this large shouldn't exist. The gravitational forces at play should tear them apart or cause them to collapse into moons within a relatively short cosmic time frame. Yet here they are, defying our models of ring dynamics and planetary formation. Some astronomers suggest the rings might be temporary, perhaps the result of a recent collision or capture event. Others propose that J1407b might have unique gravitational properties we don't yet understand. The discovery challenges everything we thought we knew about ring formation. Saturn's rings, once considered the gold standard of planetary ring systems, are revealed as modest by comparison. J1407b possesses a ring structure so vast it exists at the theoretical limits of what gravity should allow. If rings can grow this large around one planet, what other extremes might exist in the unexplored reaches of our galaxy? Number 4. TRES-2b. In 2006, astronomers using the Transatlantic Exoplanet Survey discovered something that shouldn't exist. A gas giant orbiting a sun-like star 750 light-years away was reflecting almost no light at all. TRES-2b, as it became known, absorbs more than 99% of the light that hits it, making it darker than coal, darker than black acrylic paint, darker than any planet or moon in our solar system. The darkness is profound and deeply strange. Most gas giants reflect significant amounts of light from their stars. Jupiter reflects about 52% of incoming sunlight. Saturn reflects approximately 47%. Even distant Neptune, despite its deep blue color, reflects 41%. TRES 2b reflects less than 1%. It's not just dark, it's the darkest known object in the universe that isn't a black hole. What could make a planet this black? Scientists have proposed several theories, none entirely satisfying. The planet orbits extremely close to its star, completing a full orbit in just 2.5 days. This proximity creates surface temperatures exceeding 1,800 degrees Fahrenheit, hot enough to vaporize certain chemicals in the atmosphere. Researchers believe light-absorbing compounds like vaporized sodium and potassium might be present, along with titanium oxide, which could be acting like a cosmic light trap. But these theories struggle to explain the sheer completeness of the darkness. Something about TRES 2b's atmospheric chemistry is absorbing light with unprecedented efficiency. The planet isn't completely invisible. It emits a faint reddish glow from its own heat, giving it an eerie, ember-like appearance against the blackness of space. TRES 2b represents a fundamental challenge to our understanding of planetary atmospheres. We've discovered that worlds can be not just different from Earth, but different in ways we never predicted. This planet exists as a void in space, a sphere of darkness orbiting a brilliant star, swallowing light and refusing to give it back. Number 3. KELT 9b. In 2017, astronomers identified the hottest planet ever discovered. KELT 9b, located 670 light-years from Earth, experiences surface temperatures of 7,800 degrees Fahrenheit. This is hotter than roughly 80% of all stars in the universe. The planet's day side is hotter than the surface of our own sun. It shouldn't exist in any recognizable form, yet somehow it does. The extreme temperature creates conditions unlike anywhere else we've observed. The atmosphere is so hot that molecules cannot form. Hydrogen, normally stable even at thousands of degrees, is being torn into individual atoms. Heavier elements like iron and titanium have been vaporized into gas, floating through an atmosphere where chemistry, as we understand it, has ceased to function. Complex molecules are impossible. Only atomic particles can survive. But KELT 9b faces an even more dire fate. The intense radiation from its star is stripping away the planet's atmosphere at an alarming rate. Every second, the planet loses millions of tons of hydrogen to space, bleeding its atmosphere into the void. Astronomers have observed this process directly, watching as a comet-like tail of escaping gas streams behind the planet. KELT 9b is evaporating, literally boiling away under the relentless assault of stellar radiation. The planet is tidally locked, with one hemisphere permanently facing its star. This creates a temperature differential of thousands of degrees between day and night sides, driving atmospheric winds at speeds that would tear apart any solid structure. The night side, while cooler, still exceeds 4,000 degrees Fahrenheit, hot enough to melt most metals. KELT 9b represents the extreme limit of planetary survival. It exists in a state of continuous destruction, too hot for molecules, too bombarded to maintain its atmosphere, yet massive enough that it hasn't completely disappeared. It's a world in its final death throes, showing us that planets can exist even in conditions that actively work to destroy them. Number 2. Gliese 436b. In 2004, astronomers detected a Neptune-sized planet orbiting a red dwarf star 30 light-years from Earth. What they discovered there defies the fundamental laws of physics as we understand them. Gliese 436b is covered in ice. But this ice exists at a temperature of 800 degrees Fahrenheit. It's burning ice, a substance that shouldn't be possible. Water on Earth exists in 3 familiar states. Below 32 degrees, it freezes into ice. Above 212 degrees, it boils into steam. These transitions are absolute, governed by temperature and pressure in predictable ways. Gliese 436b breaks these rules completely. The planet's mass creates gravitational forces so extreme that water is compressed into an exotic state called ice 10. Despite temperatures hot enough to melt lead, the intense pressure prevents water molecules from moving freely. They're locked in crystalline structures, forced into solid form by the crushing weight of the planet's gravity. The ice doesn't melt because it physically cannot. The pressure is too great. This creates a paradox that challenges our understanding of matter itself. If you could somehow stand on Gliese 436b's surface, you would simultaneously burn from the heat and stand on solid ice. The water would be hot enough to scald, yet solid enough to support your weight. It's a state of matter that exists nowhere in our solar system. A reminder that the universe contains conditions so extreme, they create substances we can barely comprehend. What makes this discovery particularly unsettling is what it suggests about the diversity of planetary conditions. We've spent centuries studying water in its familiar forms, building our understanding of chemistry around its predictable behavior. Gliese 436b shows us that even the most fundamental substances can behave in completely alien ways under the right circumstances. If ice can burn, what other impossible matter awaits discovery in the cosmos? Number 1. WASP 76b. In 2016, astronomers discovered a world where the weather forecast includes molten metal falling from the sky. WASP-76b, located 640 light-years from Earth, is a gas giant slightly larger than Jupiter that experiences the most alien atmospheric conditions ever observed. On this planet, it doesn't rain water. It rains iron. WASP-76b is tidally locked to its star, meaning one hemisphere permanently faces the sun while the other remains in eternal darkness. The day side experiences temperatures of 4,350 degrees Fahrenheit, hot enough to vaporize iron into gas. Powerful winds, driven by the extreme temperature differential between day and night, carry this iron vapor across the planet toward the cooler night side, which maintains a temperature of 2,400 degrees Fahrenheit. As the iron vapor crosses into the night hemisphere, it encounters temperatures just cool enough for condensation to occur. The gaseous iron condenses into liquid droplets, and these droplets fall from the sky as molten metal rain. Imagine standing on the Terminator line between day and night, watching a literal iron curtain descend from the clouds, glowing orange-red as billions of molten droplets plummet toward the surface below. The scale of this phenomenon is staggering. Scientists estimate that tons of iron circulate through WASP-76b's atmosphere every day, vaporizing on one side of the planet and raining down on the other in a perpetual cycle. The night side likely features vast pools or even oceans of liquid iron, constantly replenished by the metallic precipitation from above. What makes WASP-76b the strangest planet we've discovered is how it combines multiple extreme conditions into one coherent nightmarish system. It's not just hot, it's not just tidally locked. It's a world where the fundamental elements of planetary geology exist in completely alien states, where the boundary between atmospheric chemistry and surface composition blurs into something we have no terrestrial reference for. WASP-76b forces us to confront a humbling reality. The diversity of worlds in our universe exceeds anything our Earth-based experience has prepared us to imagine, and weather systems exist that make our most violent storms seem gentle by comparison. If you want to see more videos like this, click the video on screen now and make sure to subscribe.